So deep learning. So already we discussed, okay, what is a deep learning? Okay, so advanced level of, okay, advanced uh, algorithms. Okay, so whatever we have seen, right, in machine learning, like logistic regression, so linear regression, SVM, KNN, Navy bias. Okay, these algorithms, okay, including decision tree, random forest, XGBoost, everything is as a like a machine learning, part of machine learning algorithm. Okay, over the period of time, what happens? So we are getting huge, enormous data. Okay, so these algorithms doesn't give good performance, good accuracy with huge data. Okay, huge data, and for this machine learning algorithms, we have to do some feature engineering technique. Okay, that's a very tedious process. Feature engineering. So we have to handle data. Okay, engineering a feature wise we have to handle. Okay, but yeah, this is a one issues, and the enormous, if there is a huge data, it's a difficult to handle. Okay, in our machine learning algorithms, huge data. Okay, that is a gp. So if you want to use, you have to like a gp our level data. Okay, then feature engineering is a main thing. And another thing is, we have a lot of so computational power. That's why everyone prefers a deep learning. Okay, deep learning algorithms. If you have a less data, okay, deep learning is not a best choice. Okay, better to go with our machine learning algorithm. If you have a huge data, so you can go with the deep learning. And normally, what did in real time? So we have normally we try with all the algorithms. We start with the machine learning basic algorithm, then go to deep learning algorithm. Okay, in some cases, in machine learning, our ensemble method normally gives a good result. Okay, if there is a there is some small level of data, 6 months data or 5 months data. If you have a huge data, so you can compare the accuracy, which one gives the best accuracy. In machine learning, you can start with various algorithms like this, and try with the ensemble, mainly ensemble techniques, and then you can try with the deep learning technique. Okay, so you can select whatever, whichever gives a high accuracy. So that is a final model. So based on the business case, you can choose. Okay, so here in deep learning, there are various algorithms are there. Okay, some multi-layer perceptron or artificial neural network. So then CNN, so mainly works well for image data set, and RNN. So RNN is a recurrent neural network. This is a convolutional neural network. This is best for image data set. It's best for table data set, and table or text. Okay, text data set. And this one is for sequential data. Sequential data. If you have any time series data or sequential text, also is a kind of sequential. One text, one word follows another word. Okay, that is a sequential data. So we can use RNN for NLP. Once you build a vector, right? So you can use RNN, okay, recurrent neural network. The advanced level of RNN is some okay, some LSTM and GRU. So there are some advanced level of RNN. Okay, so first we will start with what is a neural network. Okay, deep learning. So deep learning, it was created around 1957. Okay, at that time the name was called like a perceptron. Perceptron. Okay, we'll see what is perceptron. Okay, perceptron is nothing. It's like our logistic regression. So we have seen logistic regression. Logistic regression main property, main thing is, so in logistic regression we are using some sigmoid function. Okay, sigmoid function. So whatever we have seen, some the previous machine learning algorithm works well for some linear data set. Okay, some linear, especially some non-linear. If there is some non-linear, some algorithms like RBF, radial basis function, SVM. So SVM works well for non-linear. Okay, non-linear data, and our decision tree, random forest, XGBoost. So it doesn't consider about the linear or nonlinear. It so mainly works with the if else condition. So it works well for non-linear. Okay, these data set mainly most of the algorithm works for a linear data set. Only few algorithms. But in deep learning, so you can apply linear and non-linear. So here like a sigmoid. Okay, in logistic regression we have a sigmoid function. Sigmoid function. Yeah, do you remember 1 divided by 1 plus e to the power of minus c. The c is wtx plus b. Okay, so you remember this is a sigmoid function. Okay, if you so logistic regression the same way if you apply. Okay, here in sigmoid, okay, we will see what is perceived at the time we will understand. Okay, so that is called logistic. So perceptron, the similar to logistic regression. So here deep learning normally called as neural network. Okay, neural network. So what is neural network? Why it is called? Okay. So our brain cells has some neurons. Okay, neurons. So always connected. The neurons always connected. If you feel any sense, right? If you feel any sense in your toes, right? In the sense, everything is moves through neuron to your brain. So based on that, your brain create some command. So through that you can do some action. Suppose if you feel any pain, okay, your hand goes to that place and do some massage. Okay, because of that, because your neurons conduct all the sense or all the okay, whatever you feel, right, it goes. Suppose if you touch some fire or hot water, you feel some sense, right? So suddenly you react on. Okay, if you feel some heat or some hot water, if you touch anything on that, right? So you suddenly react. How you are getting a react that reaction? So your neurons passes all the things. Okay, neurons always connected one by one. Okay, so neurons always connected, it passes the that sense to your brain. Okay, so always brain is having a millions of neurons. Okay, so in deep learning, the neural network always mimics with our human brain neurons. Okay, that's why it's called a neural network. So more than one neuron connected together, it create kind of network. Okay, that's why it's called a neural network. Okay, so this is our neuron diagram. If you see here, so this one is okay. And so every neuron, okay, always the neuron is getting connected. Okay, so this is a one neuron. So this is some okay. This type. Okay, yeah. Here this is a cell body. This one is called dendrites in your neuron. This one is called axon terminal. This one is a cell body. This one is a main nucleus. Okay, so this is some node. Okay, connected together. So what happened, this end, right, some another neuron connect. Okay, this part is connected here. Okay, connected here, this part is connected here, this axon terminal is connected with the dendrites. And so this is another neuron. It is connected like this. One neuron is connected with another neuron. This neuron is connected with this neuron. Okay, so like this, if your body cells any feel any sense, right, it moves here. Okay, to your brain. Okay, one by one. Okay, so this one is structure of neuron. Okay, now come to here. So the dendrites is in. dendrites. So it goes to some function. Okay, this is a kind of a nucleus cells, right? So it goes to function. This one is a nucleus. Okay, nucleus. So it goes, so output, axon output. Okay, so here this one is the input of our feature, input feature. It goes to some function. Okay, so it creates some output. Okay, output. So if you okay, this is the input our data input. This is the output. Okay, it pass through some. Suppose if it is a logistic regression, so we are passing input, so it is a sigmoid function. Pass through sigmoid function, it gives the output. So in our body, what happened? Entire input goes to dendrites. It access that input. It pass through cell body. Cell body has some nucleus. It creates some function. The function creates some output. It pass through axon. So axons to some other neuron. Okay, other neuron has dendrite. It pass through dendrite. Again, it goes to some function. Okay, and that neuron always connected like this. Okay, but here I am taking only one neuron. So one neuron. So we are building that model. Okay, like this. Okay. So here normally how it looks, we'll see. Okay, there is a x1. Okay, feature 1, x x1, x2, x3, some x4, some xd. So various dimension. Okay, so everything is okay. So here everything is some dendrites that tips. Okay, so this is the input similar to dendrite. What happened? So here we are some normally we are adding some weight one. So yeah, all the input feature has some weight, right? Similar to machine learning. Okay, so dimension. So we are doing some summation, then we are making some function. Okay, so we are this one is the activation function. Okay, similar to nucleus. So in a neural network there is name called activation function. So this one is a sum. We are summing all the things. So if you remember that logistic regression, we are wt cross. Okay, wt cross, we are doing summation. Okay, this one is a summation. So in the sum here we are using some sigmoid function. Okay, we are passing entire thing to the sigmoid function. So in neural network, so we are making some function, common function. Okay, so yeah, we are using sigmoid also. This is a common function. It gives some output. Okay, so if you have a multiple feature, so you can pass through some activation function. It gives some output. This is a simple neural network, normally called as a perceptron. Okay, perceptron. So neural network, the base. Okay, single node neuron, single neuron. Only we are having a single node. Okay, so here the weight, right, how it is getting adjusted, that weight. Okay, some features has a high weightage, some features has a low weight. We'll see. So weight based on the okay, so I have seen one article. Okay, Here, what I want to say is there is this one is a neuron. Okay, this one is neuron. So neuron, our brain neuron. So here the connection, right? Some that a node, multiple node is getting connected with one neuron to another neuron. Okay, this one is yeah, it looks like okay here. What happened? So here we are using some weightage. Okay, so weightage. Suppose this one is a very important feature. It has a high weightage. So in our brain, what happened? This connection, right? This one is getting connected, is getting information is getting passed. Okay, so here instead of weightage, that thickness is more. Okay, if this one is very important, if there is anything, right, thickness is more. Okay, so that in our childhood days, so we started learning a new language, right, our mother tongue, whatever it is. Okay, that time the thickness, okay, of this line, so neural network lines is very light. Okay, there is no thickness. Okay, once we become a master in our mother tongue, what happened? Not master, once you are familiar with all the words, what happened? The thickness of neuron will be getting increased. Okay, so this one is in our biological, okay, system. It works like that. Okay, based on the thickness, we can identify. Okay, suppose if you are learning a new language, if you are familiar, so if you start to learn new things, the language related, so weightage. Okay, language is a feature, one feature. Okay, if you are learning Hindi is a new language for you. The weight initial time is very less. Once you started learning, if you are familiar with the language, the weight is getting increased. But here the through thickness, they so that we will identify. Okay, so whether it is how much the weightage for that learning. Okay, oh, after that the uh, after 70 or 80, what happens? We started, normally people started to forget, right, forget the things, right. They have very poor memory. That time the thickness of the neuron layer is a very light. Okay, very thin. The beginning also like that, end also we are having like that very thin neuron layers. But in between, through learning process, so we got that thick neuron layers. Okay, here also in our deep learning, we did the same thing. Okay, the data, whatever you are giving the data, right, through that the weight is getting adjusted. Okay, if you have a huge data, the learning process will be good. Through actually what we have done in entire machine learning process. Okay, except some few algorithms, we have adjust weight. Okay, identified the correct pattern between the input and output. That is a machine learning. Am I right? So here also the same thing. Okay, but here you can pass huge data. You don't need to bother about the feature engineering. If you just pass the data, it will adjust. Okay, through back propagation and forward features. Okay, forward things. So it will adjust everything. It will identify the correct way. Even if it is a non-linear, it works well in deep learning. Okay, that is the main agenda. So here, like our neuron thickness, so here we are having a weightage. Okay, so here normally what, so we are adding some, so intercept, right? W transpose X plus B. Okay, so instead of that, we are adding some one bias value B. So some normally value is 1. Okay, that is like intercept. We are adding some bias value here. It is called perceptron. So normally it started with him around 1957. So this was invented like a name of perceptron, and around 1986. Okay, some the guy name is I think Hinton. Okay, he was working in Google. Okay, he only introduced some other algorithm also. Okay, Hinton. He created the name called like a back propagation. Okay, so back we will see what is a back propagation. So algorithm, back propagation algorithm. The name is the problem, but here in deep learning, so one kind of a process. Okay, and that time the computational power also getting increased in 1986. That's why. So he started. So many people started. Okay, do some R&D related with the deep learning. But in 1986, we don't have much data that time. Okay, again, okay, 1995. Okay, uh, so there is no data around 1995. So only we are getting huge data after introducing that internet. Okay, those smartphone. After that only we are getting okay recent 10 or 15 years. Okay, around 1995. So they have introduced some okay some AI algorithms. Okay, and but the funding is also very less that time. Okay, so that's why in this period, people started using okay some ensemble technique and SVM and some ensemble. Mainly, people started using. If there is any competition, most of the people using ensemble technique. Okay, now also ensemble is very popular one. Very because in real time, most of the industry is using ensemble. Why? Because data. If you have a huge data, but if you build the same model with the deep learning and same model same data with the ensemble, if ensemble gives a good performance means ultimately ultimate aim is we have to build a good model, high accuracy model. So if ensemble gives a good model, so we can choose ensemble. Okay, there is no other choice. Okay, even though we implemented deep learning but accuracy is very less means where should what is the best choice. Okay, that is our decision. Okay, here so and then okay that around 2006. Okay, around 2006. Okay, around 2006. So this same guy. Okay, after 20 years, he was working with Google that time. He introduced so deep learning algorithms like ImageNet. Through ImageNet only, it's into deep learning algorithms. Okay, so he only introduced, okay, there is a input. If you pass the input, so there is a multiple layer, okay, L1, L2, L3. So multiple layer. So this input goes here, like a neural network. How our neuron work, right? Connected one neurons with another neuron. Like this input goes here, this output goes to the input of another layer, like this. So he introduced, okay, this kind of in between there are multiple layer. Okay, there may be 10 or 100 layers also there. Okay, these layers. Okay, this is called a deep learning. He introduced that. So around 2012, okay, he introduced this deep learning neural network, and 2006 he introduced some image net kind of a deep learning. Okay, so that time 2012, after 2012, deep learning became popular because lot of data. So we are having lot of data, and so computational power also we have the hardware devices availability is very huge. So through that it is getting popular. Okay, so even though the top companies like what is it Google and Microsoft and Facebook. They are Facebook. They have released so many packages. Okay, even machine learning, where the time series packages and PyTorch. Okay, PyTorch is one of the popular packages released by Facebook. Okay, PyTorch is one of like a TensorFlow, Keras, TensorFlow. PyTorch is another popular tool. Okay, so like a cafe something. Okay, and Facebook, Amazon, all the big giants, they are having a huge data. So they started looking to some R&D. Through that they introduced some smart devices like Siri, Alexa, and Google Assistant. So everything is because deep learning. They use the deep learning techniques. Okay, and self-driving cars. Sorry, self-driving cars, and this one is a deep learning, and yeah, face detection, and some smart video analytics, so video and image analytics. And in medical science we have used skincare and pharma industries, skin cancer detection through image we can analyze. Okay, self-driving also bases the image, okay, capture the image, and through that it analyze and identify the right path. Okay, that is a self-driving concept. And face, okay, everything is based on the images. And the NLP become popular, okay, text analytics through deep learning, so we can analyze. So the concept is same, okay, the vectorization, vector conversion, everything is same. After that, instead of machine learning, we are passing the data to this perceptron, okay, this perceptron multi-layer network. Okay, so that's why it's a popular. Okay, simple is, so as I said earlier, x1, x2, x3, x4. There are four input. So we are passing into some okay, summation. So we are adding weight. So this one is a feature one. Feature one has some weight. Feature two has some weight. So we are connecting. So we are W3, W4. Okay. So summation and passing through the function. Okay. So this one is called activation function. So activation function. Okay. So this one is give output. So it might be more than one output. So chances are there. Okay. So if there is a multi-class classification, more than one output. Okay. So output. So if you write in the equation, so we are passing through function. Passing final thing is function. So here W1 x1 plus W2 x2 plus W3 x3 plus W4 x4. Okay. So here what? So here we have done some summation. I is equal to 1. So n observation. So Wi xi. Okay. So this is the final equation. So this one is activation function. So in deep learning, the similar to sigmoid, okay, we will see what are the different kind of activation function. Here, and the name is activation. So we are calling activation function. Similar to our neuron, it has like a nucleus cell only redirecting, conducting. It creates some reaction in the cell. So it passes through the next neuron. Okay, like this, it activation function in deep neural network. This one is a weight. Okay, so weight. Our ultimate aim is find the right weight. This one is the input feature. Okay, input feature. So finally, so y output. Okay, so output, we have to find the output. Okay, so this is the equation. So here, what is the okay? So here the same equation. Okay, if it is a large, you can connect with the logistic regression. Okay, this function, right? This function is there are various functions. There is a one more sigmoid, right? Instead of this function, if you use sigmoid, okay, in this equation, sigmoid function, that is called a logistic regression. Okay, so we can use sigmoid function. Okay, so everything is same. So this one is a give. If it is a sigmoid, this one is sigmoid function. Sigmoid function, how it works? So sigmoid function curve normally like a S curve. Okay, if any data comes here, this is a one class label. If another, if anything comes here, okay, this is a 0.5 50%. If anything comes more than 50%, it's a part of one class label. If anything comes so less than 50%, is another class label. Okay, so the sigmoid, this one is this curve is sigmoid curve. Okay, so if you pass entire input and output, sorry, input with the, so weight is getting adjusted, okay, with sigmoid functions. So it classify the data, okay, like this. So above 0.5%, and this is a threshold, normal threshold. So in our case study, logistic regression case study, so in some business cases, we can change the threshold, okay, through probability score. If you know the probability score, if there is anything, suppose if you set the threshold as a 0.6, Six, okay, this is not this is out of topic here, so just for sharing the knowledge. So this one is a thumb rule. Okay, if percentage, if probability is more than 50%, okay, this is a class level 1. Less than 50%, class level 0. You can decide or you can change the threshold. Instead of 50, you can set it at 70. If anything more than 70% probability score, zero point 0.7, so you can set it a classify as a 1. So if anything less than 0.7, you can classify it as a 0. Okay, as a 0. Okay, so you can decide, but a default every places 50%. Okay, so here also 50%. Okay, here we are following sigmoid function. This function is sigmoid. Instead of sigmoid, there is a ReLU function, tanh function, and various other function. Okay, ReLU something. So we'll see all the things one by one. So if we pass any other function, that is deep learning. Okay, neural network. Here we are using only one node. Okay, this is single neuron. Single neuron or perceptron. Okay, single neuron or perceptron. Perceptron, single neuron we have connected. It has some function, and if you pass the input and adjust the weight, and it gives the output, that is called sync. Instead of this common active function, if you use sigma, is a linear logistic regression. That's it, very simple. Okay, so now we are going to see about a perceptron. Perceptron is, so we are passing to through neuron. Okay, this one is neuron. So neuron or node. Okay. This one is a single neuron. Okay. So normally how it looks. Okay. So there is a x1, xi1. Okay. Normally xi means observation, I1 to n. Okay. This one is the first feature. Okay. Feature 1. xi2, second feature. Observation. So it varies I2, I1 to n observation. xi3, xi4. Okay. So there is okay. Now instead of single neuron, so here we are going to see multi-perceptron. Okay, sorry. So multi-layer perceptron. What is single neuron? We have discussed only single neuron. It is so multi-layer perceptron. Okay, so here, so there is the input. Okay, so if you round this, okay, there are various features. Okay, so 4 features. Okay, so it passed through instead of single neuron, so we are having some function. Okay, we'll note it, some function f1, f2, f3. This one is a node, this one is a input, this one is layer 1. Okay, input pass through this. Okay, these functions. Okay, here we are passing. Okay, I'll change the color. So all the input. So all the input pass through function. Here we are using more than one nodes. Okay, in this layer 1. Okay, so similarly we are having some other layer also. So we can implement any layer or n number of layers, doesn't matter. Okay, if this one is 1, this one is second layer 1, f2 2 second. So here once we pass the data, it has some weight for all the lines, means some weight. Okay, so we are summation. Okay, x1 multiply with y and pass through some function. Okay, so here it gives output, it goes here, another layer 2. This one is a layer 1, this one is a layer 2. Okay, so then there is one output layer, so it passes here and it gives the output. Okay, output also has some function. Okay, So here this is output. So here we are using layer, okay, more than one layer, multi-layer, okay. You can use hundreds of layer, doesn't matter. That is a deep. So deep learning. Sorry, like in decision tree we have deep depth, right? Like this, we have this like a decision tree, but here we have connected all the nodes, okay. It's a deep neural, okay, a deep network here. So you can increase and decrease. This one is a one kind of. So how many nodes you are using, how many layers you are using. So that is a hyperparameter here. Okay, we have to adjust everything. Okay, this is a multi-layer perceptron. Okay, everything is normally L1, L2. This is the input layers. It is output layer. In between these two layers, you can create n number of layers. So these layers are called hidden layers. Hidden layers. Okay. Okay. So do you have any questions here? Okay, there is some playground dot TensorFlow. So if you get a chance, okay, definitely go through it. Okay. So there is okay four different data set here. Okay. So it has some X1. Sorry, excuse me. It has some input feature X1 and X2. This is some feature engineering transformation. X1 square, X1 2, X1 X2, like this sign of X1. This is a transformation. Okay. So we'll start with some. Okay. So ratio of a training data set and test is 50%. The split is 50-50. So noise, if you want to add some noise, so you can add, if you increase the noise here, so you can see some other colors, okay, in between them. So we normally we set it as 0. Okay. Batch size, okay, 10 data, okay, batch size, and the batch size is split, the entire data set is split into 10 batches. So here in the top portion, you have seen some epoch. So how many iteration, okay, for the entire data set? One epoch means the entire data set finish their training. That is a one epoch, okay. So even though 10 batches, 10 times it is again, that is a one epoch, okay. Learning rate. So in gradient descent, we have gradient descent. We have how the learning rate. If you we have discussed learning rate in when we discuss the optimization, the gradient descent. Okay. So in gradient descent, what we have discussed, if you adjust the weight, how much okay, for gradient descent mainly optimize. Okay, we have to find a right weight. Okay, it gives loss function. We have drawn the diagram between loss function and weight. So you have seen, right? So we have seen like this. Okay, this is a loss function. This one is the weight. So if you adjust the weight, the loss is here is a minimum. So this whatever the weight we are having here, this is the right weight. So weight start from here and it moves here, 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 here. If learning rate is high, it moves like this. If learning rate is small, so it moves the next question, next question, next question. So learning rate, so we can adjust that. So activation, here you can see various activation functions. So here, ReLU, TANH, sigmoid, linear activation. So there are various, okay. If there is a non-linear, so you can use a linear activation. Okay, okay. We'll see sigmoid. And regularization, whether it is a L1 or L2, a regularization has some lambda value. So we can set a regularization rate here. So we are here setting sigmoid. Okay, so we will see some L2. Okay. So this one is the input data. See here, there is two different colors. Okay, so non-linear data. So here, how it is classified? Okay, the color. Okay, the background color will classify that. Okay. So if you want to adjust hidden layer, you can increase the hidden layer. So it looks like this. If you want to reduce, you can reduce the hidden layer. Okay. So Okay, so we'll start with sigmoid. Okay, increase some hidden layers. Sorry. So here you can add neurons. Okay, like this. So you can add neuron. So you see weight, you can adjust the weight. Okay, so everything is weight is available here. So I will start execute run. Okay, so if you see here the test loss and train loss, through that you can predict whether it is overfitting or underfitting. If a test and train has a huge difference, that just means your data your model has overfitting issues. You see here, wow, so it works well, right? So stop here. Okay, so you can see that, right? Even though if it is a not non-linear, what happens? So correctly classified. Okay, so this one is the power of neural network. Okay, so the outer data points are classified with a different color, background color. So inner, this is a separation region, right? Separation region. Okay, so clearly separated. Okay, so through that, so we you can play with it. Okay, with the various data set. Suppose if you want to remove one hidden layer, so then try it again. Okay, what happened? Okay, so then try with some other function, relu. So clearly classified. Try with some other data set. Okay, we plan this data set how it works. Okay, so you can see here. Okay, with the test and train losses. Okay, so there is some huge loss. The graph itself says the huge difference. Okay, so overfitting issues. Okay, and there is no changes after. So, okay, then try with some other. Okay, like normally Sinex introduce some layers, some neurons, some other neurons. Just randomly I'm using. Okay, I'm not sure which one is working. Select some sigmoid function. This one is activation functions. And play it again, we'll see what. Mhm. No, right? The bottom color is one different, and the top portion is another color. So the separation is different. Okay, so it's wrongly classified. You see, test losses. Okay, zero point 0.5 training losses also fine. Then remove hidden layer. Add this input. Right. So you can play with the okay various data set. Or you can adjust the just to play with it before entering to the deep learning. Okay, some algorithm. Just play with it. Okay, try with the various learning rate and various data set and introduce some noise and so without this transformed features. So just try with some normal features. Okay. Okay. So we will see tomorrow. Okay.